function values of 90 degrees minus theta and 90 degrees plus theta. Obviously, on the previous lesson, I've taken you through the function values of 180 degrees minus an angle, and another one for 180 degrees plus an angle, and lastly the one for 360 degrees minus an angle. And I'm pretty much sure that you understood how you apply those reduction formulae. So for now, I'm therefore going to start with the function values, maybe this one of 90 degrees minus theta. So maybe let us look at a situation where, let's say, you have sine into 90 degrees. What do? Let's maybe minus it with an angle. We will also look at another one where we have cos 90 degrees where we minus an angle. I'm therefore going to train you on how you apply this reduction formula. So if you remember, we are still continuing with our cast diagram. On our previous lesson, we looked at the angles along the x-axis or the horizontal line. So today we are going to be looking at the angles along the vertical line or the y-axis. Obviously, those angles, here we are having 90 degrees, and then here we are having 270 degrees. Okay. Then it's fine. So let's look at this. Obviously, 90 degrees minus, it will be an angle that falls to the first quadrant. But if it's 180 plus, it will be an angle that falls into the second quadrant. And then I'm pretty much sure that you can already see that if m is 270, then it has to be minus so that it falls in this quadrant. And then if we say 270 plus, it will fall into this quadrant. So now how do we reduce that? So this is how you interpret it. This is exactly how you interpret it. You see there you have 90 minus an angle. The first thing that you ask yourself is to say, in which quadrant does this fall? That you already know. It falls in the first quadrant. Then you say, in the first quadrant, is this positive or negative? It is positive, because in the first quadrant all trigonometric ratios are positive. The special thing about this one of 90 and 270 is that it changes to cos, which means you will therefore say positive cos of an angle. That's how you reduce it. That means with this one, you will therefore say, in which quadrant does that angle fall? In the first quadrant. In the first quadrant, is cos positive or negative? It is positive. Therefore, it becomes positive sine. It has to change its trigonometric ratio. So if it's cos, it changes to sine. If it's sine, it changes to cos. It is as simple as that. So you will therefore realize that what I've just explained, it's not complicated, but the reason why you will get it wrong, it's because of you forgetting or confusing or not being confident with it. So that means you need to do it as many times as you can. The only way to prove if indeed the left hand side equals the right hand side, if you choose to use angle 30 there, also put 30 there, you will see it will give you the same thing, which means you'll say sine into 90 minus 30, and then you also punch cos 30, it will give you exactly the same answer. Even with this one, you say cos minus, you can change and say 60 there, then again you say sine 60 there, it will give you exactly the same answer. That's how you verify if you have reduced it correctly. So, not that much complicated, it is as simple as that. So, let's now look at the other function, the function where we have 90 degrees that we have to plus it with an angle. Obviously, in this case, again, we can talk about sine of 90 degrees that we will plus it with that angle. We will find out what that is, and then again we will look at the one for cos of look at that 90 cos 90 degrees that we will have to plus it with an angle, and then we'll try to find out how that looks like. Most importantly, you will always need this thing, cast diagram. You will definitely always need the cast diagram. So let's see, how do we interpret it the same way? You will say 90 degrees plus an angle in which quadrant? In the second quadrant. In the second quadrant, is sine positive or negative? It is positive. Okay, in that case it means it will become positive cos of an angle. Why cos? Because it is that complementary angle, so it has to change from sine to being cos. And then this one again, we will say 90 degrees plus an angle. In which quadrant does that fall? It falls in the second quadrant. So in the second quadrant, is cos positive or negative? It is negative. Therefore, it becomes negative. It must change. That's why it is becoming sine of an angle. It is as easy as that. Trust me when I say this, it's not complicated. It is just as easy as I've explained. It may be confusing if you do not do too much of these things. The only way you can be confident with this type of problems, that's if you do a lot of examples. I'm just going to do a few, and then from there I will definitely give you something to practice so that you get used to them. So let us say we are given a problem of which you are having, let's say, cos into 90 degrees, and this thing is being added to an angle. So these are the type of the questions that you might need to expect in your school test, even in an exam. They will look more or less the same as what I am doing, even though in an exam somehow they might try to be tricky, but trust me when I say you will apply all this that I've explained. Where you are given this, how are you going to therefore work it out? You just look at this thing at the top. I'm sure we have done it already. Cos 90 plus, all that you need is this. You don't need to go back to what I've already done and check how it looks like. You just need this and say 90 plus falls in which quadrant? It falls in the second quadrant. In the second quadrant, is this cos positive or negative? In the second quadrant, it is negative. Therefore, this numerator will become negative sine of an angle. It has to change from being cos to being sine. Then at the bottom you've got 360 minus an angle. For 360 minus, it falls in which quadrant? It falls in the fourth quadrant. Be careful here, it doesn't change, but it becomes that same sign. But just remember that in the fourth quadrant, sign is negative. It therefore becomes negative sine of an angle. Yes, you might be wondering, why is it sine and it's not changing? Remember, you have two lines that you are working with. That's why I said you will just be confused, not that it's difficult. You remember we said angles along that line, they don't change. It is only the ones along this vertical line which change. So this one for the denominator is 360 minus, it doesn't change. So now once you've done this, or once you've applied the reduction formulae, then it's easy. That cancels with that cancels with that, and then you remain with 1, and that is the end of it. So if you want to prove it, you will always just choose any angle that you like. For me, I can put 30 there, 30 there. Then if you punch cos into 90 plus 30 over sine into 360 minus 30, it will definitely give you 1, or it must give you 1. Doesn't matter whether you use 60 there, maybe 45, as long as you use the same angle, it should and it will give you that. I hope that part makes sense. Maybe let me look at another example, maybe a more realistic exam type of a question. Let's see. Maybe let me get a black pen there and say, okay, let's say this example B, and then let's say you're given this. So they just combine too many of these things with the hope that you will get confused. But if you just make sure that you pay maximum attention, you will definitely never go wrong. And then this, it's multiplying. I don't know why this thing, my marker, it's a bit slow today. I wish to find out what the issue could be, but otherwise it's fine. Let's see, we have cos of 90 degrees. I'm pretty much sure that you can already see where this is going. And then we have minus an angle there, and this we multiply it by cos, and we are having 360 degrees, and then we are having minus that. So it's okay if you are rewriting this as I'm writing it, but as I work it out, do not work it out so that you can see how it has been done, and then once I'm done, you will try to work it out. So obviously, what did I say? Let's see. So that means you will say this thing, it falls in which quadrant? In the fourth quadrant. In the fourth quadrant, this thing is negative. For that reason, you will put it inside the brackets and say negative sine of an angle. That's how you will decisively deal with this one. Then you'll say times, and then this one, again, let me just use a different color to show you that these things, it's like they've taken those smaller things and then grouped them together. 90 plus, in which quadrant? Second. In the second quadrant, is sign positive or negative? It's positive. Therefore, no need to write it inside the brackets. You just write it as it is. Only if it's negative, put it inside the brackets. Always. You'll never go wrong. Then let me remember to choose a different color there and say 90 minus, in which quadrant? First quadrant. First quadrant, is this thing positive or negative? It is positive. But because it's 90, it must change to sine. So you can see that it's just a combination of these confusing things. Oh, wait. Can you see that already I'm the one who got confused? You see there, it's not supposed to be sine, but it is supposed to be a cos. Yes. Is it not supposed to be cos? It is supposed to be cos because it is that one of 90 plus. Yes. Let me quickly rectify that. So can you see, I probably made that mistake deliberately so that you can be able to see how you actually, what color was that? Maybe let me just choose this one. I'm not sure what color that was. So that means it is therefore supposed to be cos of an angle. Very much important there, because if you are not being careful in doing that, you are definitely going to be in trouble. So that means everything from that step going down is wrong, because I forgot to change that. So that's how you can make a mistake with this type of question. So just always be careful as you are working it out. So you see this one for 90, I've changed it. And then let's see this one in which quadrant? Fourth quadrant. And then does it need to change? Nope. And then it means in this fourth quadrant cos is positive. Then you will just write it as cos of that. Trust me when I say once you've done this, you are done, because all that you need to do is just to cancel the ones that cancel. Definitely this one cancels with that, this one cancels with that, but you have that invisible -1 there. That's why your final answer will be -1. The nice thing about this is that you can verify if your answer is wrong or correct. How do you do that? You can just put same angle there. If you put 30, put 30 there, 30 there, 30 there, 30 there. Punch all of it on your calculator. Trust me, it will give you exactly that. So that's how you would actually prove if your answer is wrong or if it is correct. Maybe let me take you through the last example, and from there we will see. From there we will definitely see how we are going to work it out. So let's see exactly how. Okay, maybe let's say this time around you are given, let me look for that example. This equals that. I'm just trying to figure out if all that I've covered is enough for you to be able to approach the other examples. Yes, I think what I've covered is actually enough. So just to give you an idea, because at some point they might give you something like let's say tan of let's say 90 degrees. Maybe this one, let's just plus it with theta, because I know you might be wondering to say, since the trigonometric ratios we are having sine, cos and tan, then what if it's tan? You just need to remember that tan is actually the same as sine over cos. That is tan. It's the same as sine over cos, whereby you will therefore end up having this same thing but being like this. That plus that. And then again, that means it will still be the same thing of 90 degrees plus that. Can you see now? So you just do what you know. 90 plus which quadrant? It is the second quadrant. But remember, it has to change. It becomes positive because sine in the second quadrant, it is positive. then over 90 plus second quadrant again, but cos is negative in the second quadrant. That's why it becomes negative sine of an angle. Okay, trust me when I say the moment you have cos at the top, sine at the bottom, this thing is the same as cot. It is the reciprocal of tan. So remember, you still have that negative there. So it's like you are having negative cot of an angle. And you see, so that means as a mathematician, you should therefore say it means if it is given to me as a tan, I can just say, okay, 90 plus is in the second quadrant. In the second quadrant, is tan positive or negative? It is negative. For that reason, it becomes negative. So that means tan changes to cot. Then it becomes negative cot of an angle. So that means if it is given to you as tan, it doesn't matter whether it is 90 degrees minus an angle or it is 270 degrees, whether plus or minus an angle. As long as it is tan, it will therefore change to cot. Regarding the sign, you just interpret it the same way to say in this quadrant tan is positive or negative. If in that quadrant it is positive, then it becomes positive cot. If it is negative, negative cot. Maybe let me be fair and give you a practical example and say, let's say this time around is 270 degrees, let's say minus an angle. So this one, it will be turned into that. So you'll see 270 minus which quadrant? Quadrant number 3. In quadrant number 3 is tan positive or negative? It is positive. Then it means it changes to becoming positive but cot of an angle. So that is the end of it. But if it was positive there, see there, it was not minus but it was positive, tan into 270 plus angle, it would be in which quadrant? Fourth quadrant. In the fourth quadrant, is tan positive or negative? It is negative. It therefore becomes negative there, and then it changes to cot, and that should be the end of it. Doesn't matter whether there it is a minus. If it is a minus there, then it's in the first quadrant, and in the first quadrant all trig ratios are positive, meaning tan is positive, but because it's 90, then it changes to becoming a positive cot. So I think I've just covered all of them, even though officially we talk about the sine and the cos. But if for some reason you are dealing with the tan, just remember that you can work it out as that over that, or remember cot. And that should be the end of it. Let me just quickly check if I've covered everything, but I'm pretty much sure that you fully understood what I've explained there. Okay, it looks like I've covered everything, and it is that time where I need to say until we meet again.